Good morning, students, and welcome to the last full week of Quint 5. I hope you aren't too stressed out right now by all the all the things you need to finish up in your last couple classes here. But the end is near, so congratulations on working so hard and doing so well. And we're just going to clean up a couple of things today and get you ready for the second Python unit exam, which starts tomorrow. And so 4.8 is the last sort of concept area in Python, and it doesn't actually pop up much at all on the second unit exam, but it is something that I want you to be aware of as you move forward in computer science, so that you can do a good job of taking in user data and giving them feedback on what they need to give you in order to have your program function properly. So for a lot of our programs up until this point, you've asked the users for input, and if they give you good input, and I've told you on the exams, if you ask me for something, I will give you exactly what you asked me for. But we all know that users are going to make mistakes, so we want to try to account for those mistakes in a way that doesn't break our program and stop it from running. For a lot of the programs that we've taken in input for before, if they give us bad data, we don't always have systems in place to catch those errors and give them a chance to correct them, and oftentimes it'll just break our program, and you'll get those red type errors and stuff like that at the bottom of your screen. So you don't want that to happen in a live environment, because then you have to completely restart the program over again, and you confuse users because they're not going to understand what those error codes mean. So we want to put in some structures that can help us make sure that we get good data from users. And we're going to use, in this particular language, something called try and exception handling in order to make that happen. So this is just a brief overview of what we're going to look at today. And we're probably just going to focus on the first three because they're the most important. Okay, so this is just a quick review of the things that that I discussed on the prior page. We encounter errors as programmers, but also users will encounter errors if they make mistakes in their data input. So those always happen at runtime, and when they happen, you get something that's called an exception. And that's really just the little red code at the bottom that tells you that there's some error that Python can't figure out, or it wasn't programmed to figure out by you. And it just gives you an error trying to tell you where in the code the error occurred, and you know what you could possibly do to fix it. And we've become pretty good at looking at some of those errors and being able to diagnose what the problem is. For instance, if we see an index out of range, we know that we tried to access a character in a string that doesn't exist, or an item in a list that doesn't exist. You won't see the file not found error because we're not doing any file import and writing in this class, but you may have seen a zero division error along the way where you tried to divide by zero or something like that. So when that happens, Python creates a special little block that's called an exception object. And if we handle those, we learn to handle those properly, we can make it so that our program doesn't break. It continues to run, and it continues to process data and gain inputs and do things that we need it to do in order to get to the end of our code. So that's what we're going to focus on today. This is probably the most, this would be a common error that would pop up. If we look at our code, we've got a equals 5, b equals 2, c equals 0. Now, printing a divided by b is not a problem. They're both integers, so we should get 2.5, which we do down here in our output. But when we try to divide a by c, which is 5 divided by 0, we know that that's an undefined situation in mathematics, and it is in computer science as well, or in programming. So you notice that they've got this this exception raised at the bottom, and you've probably seen errors like this before. Maybe not exactly the zero division error, but you've seen other errors. And it stops your code, it breaks it, and then it tries to tell you, hey, there's a problem here. And in this specific case, the problem is on line 6, where it asks us to print a divided by c, and the error we get specifically, is a zero division error, and it just says division by 0. So when we look at that as math students, we know that that makes sense. Oh yeah, that's an situation in math. So we must have done something wrong. And same thing in computer science, it tells you exactly what it is. So so that's the problem with this one, and this traceback error is telling you exactly what it is. Now that's helpful for you as a programmer because you know where the error is and you know hopefully how to fix it. But a user's not going to know what to do with this. And so we've got to program this in a different way so that it doesn't instantly break. So the way we do that is called exception handling. And we just write some specific code blocks that ask the user or asks Python to try something. And if that doesn't work, then we can use a different block called an except block that's going to give a specific error but not break the program, or give the user a specific message and not break the program. And then it's going to, you know, if you've got it in a loop, you can get it to try again, try again, try again until you get the data that you need and then no error occurs. So if it does the try section of the code, it's kind of like an if statement. If it does the try section of the code and it doesn't throw any errors, then it just breaks out of that try block and then goes down to the next line in your code. So it's either going to do the try and be successful and then skip out of that and go to the rest of your code, or if the try fails, it's going to go down to the except statement, and then it's going to try and do the logic in the except statement and either give the user a message and let them try again, or just give the user a message and move on to the next line of your code. It's going to do one of those two things. Now, it's not a loop. It's not built in that if you try something and it fails, then it goes to the exception and then it tries again. That's not built in. It's just you know, straight from top to bottom. It's going to try something. If it doesn't work, it's going to throw an error. You're going to do something in that section, exception section, and then it's going to jump to the next line of your code. The important thing is that it doesn't break your code either way. But we're also going to look at how to loop these things so that we can give users another chance to input data. So I'm just going to flick over to switch over to PyScripter right now, and we'll just look at a specific instance where we won't be able to make our try section work and show you how the exception and the exception work. So let's just set up the variables, very same that we did in that we saw on that slide. Oops, we're going to have a equals 5, we're going to have b equals 2, we're going to have c equals 0, and we can do any number of things with those. We can print c divided by a, because that's just 0 divided by 5, which is going to give us 0. We could do print b divided by a, which is going to give us 0.4, and we run those, and we have no problem with those. We should know what we're doing with those by this point. But once we get to a situation where we're trying to divide by 0, now we're going to pop that error that we saw in the slideshow there. So we've got the exact same 0 division error, and it breaks our program, and our program stops. So what I'm going to do is I'm just going to put a print statement down here that says program finished, just so we know that we got past the section that caused us problems before. We made it all the way down to the end of our code. What we're going to do here is, instead of just hard coding these expressions in, we're going to put them in a try block to see if it can actually do what we ask it to do. And if it does, that's great. And if it doesn't, let's try and catch that error and give the user some input on what went wrong. So for instance, what we're going to try to do is let's get some input from the user. So we're going to set a equal to 5, and then we're gonna maybe set a variable that's user num, and we're going to get that as an integer and the input, and we'll give them a little prompt that says enter a number, and we'll try to be as specific as we can, not 0. All right, so we're telling them what we want, but we know users make mistakes. So what we'd like to try to do is we'd like to take we'd like to print a divided by whatever they enter as the user number. And if that goes well, then it will execute the try statement. Oops. Okay, so it'll execute the try statement, and then it'll jump out of the try block and finish the program. However, we need to have, or we should have, an except block as well, and this is what we're going to use to catch any potential errors. So for this case, the only likely error that they're going to have is that they entered 0. So for our print statement, we could just say, you know, you entered 0. Read the question again, or read the prompt again. And now it's not going to loop automatically, but we're just telling them what their error is. So if we do get any error on this one, it's going to print this line and not break and get to the program finish. So either way, it's going to work on this one. In the try, if they give us a good number, it'll just print out what the division of those numbers were. So maybe I should just be a bit more specific here. Your 5 divided by your number equals, and then it's going to be whatever a divided by usernum is. And then, so it's either going to work there, and if it is successful in printing this line, it jumps out of the try except and goes down to program finish. If it fails the try and it raises an error, it's going to go down to the except, and it's going to say, you entered 0, read the prompt again. It's not going to loop. We don't have it set up to loop yet, but it is set up to not break our program and to give the user a little information about what the error was. So let's run this and let's see what happens. It's asking me for a number not 0. If I put in 5, okay, it should say 5 divided by your number equals 1.0, which is correct. Which is correct. So the try section of this was successful, and again, it's Boolean, right? The try is not specifically written into the program, but it's built into the program. So when it's looking at try, it's looking at either true or false. If your program works and doesn't throw an error, that's really just saying the try was true, and if the try was true, then it worked, and then it skips over the except and goes to the rest of your program. If the try is false, meaning it failed, error, then it goes down to the except, does whatever you want it to do in the except, and then breaks out of that and goes to your program finished. So in this case, I gave good data, and my program printed, and it was fine. So it didn't need the except; it skipped over it, went to program finish. So that's great. But what if we have a user who isn't paying attention and puts in a 0? Okay. Now you'll notice that we didn't get our try section printed out. We got our accept section printed out. So it went to the try, it tried to divide 5 by 0, it raised an internal error, which you notice it's not displaying for you down here. So as soon as it found out that try wasn't going to work, it's going to be false, it skipped down to the accept section, and it told the user, you entered 0, read the prompt again, and then it finished the program. Again, we don't have a loop built in to give them a second try on this. We're just making it so that instead of our program breaking, it doesn't break. It gives the user some more output and some more information about what they did that was incorrect. And then it went to our last line of our program, and nothing broke. It finished. And in this case, our last line of our program was just program finished. But you can imagine if you had several hundred lines of code to execute after the try except, and it breaks right away, you never get to that code. You never get to the next steps of your program. And it's kind of a game changer, right? It mixes the program, and you're not going to get the user to do what you want them to do. So there's just a quick example of how you can use a general try and except to take in data and give some sort of output either way, whether it was good data or bad data, and then make it so your program doesn't break. But we're going to use it in some slightly more effective ways in order to make sure that we get the data that we want, because we don't want the user to have to restart the program again and do it that way, because that's frustrating for users for sure. Okay, so this is basically what we just did, except I used an input statement. Now it's trying to print 5 divided by 0, and because it can't, it says there's some problem with your code. In this case, it was just a very generic message that said, can't do what you want me to do, and this is the reason, and it's not going to break your code. So in your except blocks, we had kind of a, zoom in here, but we had just a plain except colon, which means if it throws any error whatsoever, if we get any exception error, it's just going to do what you want it to do down here. But you can also tell it to look for specific things. So in this case, we did a try, and we're trying the exact same thing, and our exception this time is very specific, zero division errors. And if we're looking for a specific error, we can give the user a specific message that tells them exactly what's wrong with it. If we don't have a specific error code written in here, the program may have broken, and we may have gotten our except function working or our except block working, but we might not necessarily know what the exact problem was. And if we don't know what the exact problem was, we can't give the user good feedback. Basically, all we can say is something's wrong, I don't know what it is, but that might not help the user much. So if we start using specific exceptions, we can narrow down the possibility of what that error was for the user, and as such, we can give them better data on how they fix it. So if we flick back over to PyScripter again, you notice I've got just this blank exception block. But what if that wasn't the problem? Let's say I have a list that's got some items in it. And let's just say it's got a couple of integers in it. So I've got a very short list. It's only got 2 items. I've got a 1 and a 2. And we know that the 1 is in the 0th position because we start counting at 0. And we know that the 2 is in the 1 position. So what happens if we try to access my list 3? Well, there is nothing in the 3 position of the list. There's only 0 and 1 right now. So if I try to access something from that list that doesn't exist, I'm actually going to get a different type of error. So what I'm going to do is I'm still going to take in a number. I'm not going to use it right now. And or maybe I will. Maybe I'll add it to my list. So maybe I take this this information, and I append it to my list. So in order to do that, I've got to set this up properly. I've got to do my list at the very beginning, dot append. That's how you add things to lists. And what am I going to append to that list? I'm going to append whatever they enter. So I'm going to take what they enter, put it into my list. So there's going to be 3 items in the list. There's going to be a 1 in the 0 position, in the 1 position, and then whatever I enter is going to be in the 2 position. But I'm not going to have anything in index 3, 4, 5, or so on. So what if I make a mistake, and what I'm trying to do is print out something that doesn't exist in the list? So for instance, if I try to print out whatever is in position 3 in my list, it's not going to exist because I'm only getting them to input 1 number. So if I try to print my list and then the 3rd index position of my list, we know that that doesn't exist. And that's going to throw an error. And it's going to throw an index error. And I'm not prepared for that index error. So watch what happens when I run the code. Eliminate my list. Oops. That's a completely other error. My list equals 1, 2. There we go. So enter a number, not 0. It doesn't matter what number I enter. It's just going to add it to my list. So I add it to my list, okay? And then I tried to print my list 3, and we know that's going to give us an error because there is no item in my list 3. In fact, I'm going to print out, before we get to the error, I'm going to print out my list just to show you what's actually in the list before we make a mistake with it. So if I enter a number 4 in my list, you notice it prints out the list 1, 2, 4 because I had the 4, but this is index 0, index 1, index 2. There's nothing in index 3 or 4 or 5 or 6. We don't have that many numbers in our list. So it was able to access the first line and print the my list, but when it came to the second part, which says specifically to print out whatever is in index position 3 in my list, that index position doesn't exist. So it throws an error. But our accept block is kind of a general catch-all at this point. It doesn't matter what error is thrown, it's going to run the accept portion. So what it's printing is you entered 0, read the prompt again, but that's not the error we made. Okay, the error we made is that we tried to access something in the list that didn't exist. So we gave them, in this case, the wrong feedback, which isn't going to help them. And if we wanted to write an accept error for this, we don't know necessarily what the error is, so we'd have to do something general, like there's a problem, but we don't know what it is. Whereas, if we put in a specific exception code, we know what data we're getting and how it's incorrect. So for instance, let's try to divide by 0 again. So let's do oops, we don't have a b variable anymore, so I'm just going to go throw b equals 0 up there. Okay, so now we can try multiple things, and we're prepared for multiple errors, or we will be prepared for multiple errors. So the first thing we're going to try to do is we're going to try and print a divided by b, which we know is going to give us a specific error. It's going to give us a divide by 0 error. And then we've also got print mylist3, which we know is going to give us an index out of range error. But because we don't have any special exceptions set up with, if it throws an error, we're not going to know what it is. So let's set up some specific codes that catch certain types of errors, and then we can give the user good feedback on what they need to do differently. So if I'm going to have an exception, that the first exception is going to be a what is it? Divided by 0 error. You have to get these right. You have to get these just right. And sometimes I have to go back and reference 0 division error. That's what it is. Okay, so let's go back to there. So we're going to specifically look for a 0 division error. So 0. And once you start typing it in, if you're in PyScripter, then it tells you, oh, that's what it should be. Okay, so if I'm looking for a 0 division error, it's going to print, we know that you tried to divide by 0. So because it throws this particular exception, we can give the user good feedback. We can tell them, in this case, you tried to divide by 0. Okay. And then we can make another exception, except that takes care of the index out of range error. And once again, I don't remember exactly what the name of that error is, but I'm sure I've got it in here. Type error, runtime error, value error, type error, global type error, low data type error, index error. There it is. Okay, so I'm just going to go back. And we'll put in a specific index error exception. So I'm just going back here. When we go back to PyScripter, we're going to put in another exception. This one's going to be specific as well. So our exception on this one is going to be type, no, not type error, index error, sorry. Index error, there it is. So if I get an index error, meaning I'm trying to access something in a list, or if I'm trying to access a specific character in a string and it doesn't exist because the number or the index I tried to use is too high or too low, it's going to give me the opportunity to give the user some specific feedback on that. And I could say something like that item does not exist in the list. So now, based on what error my try section throws, I'm going to get a specific exception that I can handle individually to give the user good data on what they made a mistake on. So when I run this now, it's going to try, and it does it in order, so it's going to try A divided by B. So it's going to try 5 divided by 0, and that's clearly going to give us a 0 division error. So it's going to go down to the except section and say, oh, there's 0 division error. So if they make that mistake, we're going to print this code. And then it's going to skip out of the except and go back to program finish. So that should happen here. It's going to ask me for input because that's part of my program. I put in 5. It didn't matter what I put in because the first thing it tried to do was divide 5 by 0, and that gives us a 0 division error. So you notice the only thing that it printed was you tried to divide by 0. It skips over the index error part because that wasn't the first mistake it found. So it went to the 0 division error, told me I tried to divide by 0, skipped out, finished my program, didn't break it. Now, if I take this out, maybe I switch these two around. Instead of trying to go 5 divided by 0, I'll go 0 divided by 5, which is acceptable because that's going to just give us 0. 0 divided by anything is 0. So it's going to be successful in this part, but then it's going to break when it gets here because I'm trying to access something in my list that doesn't exist. And really, anything less than 0 or anything more than 2 is going to give us an error. So it doesn't matter what index I try to access. Clearly, there aren't 1,100 or 1,101 items in this list, which means we know that we're trying to access something that doesn't exist in there. We know that we're going to get an index error. So this time, we're hoping that we don't get the 0 division error because this will not generate a 0 division error. But the second line, the second print statement, is going to give us an index error. So we're hoping to see that this item does not exist in the list. So I'm going to enter something into the list. And then you see that it gives us the error that that item does not exist in the list. And what you should notice as well is that it actually did the first thing in the try list because that was successful. It tried to print B divided by A, 0 divided by 5. That's successful. So here's the output, 0. And then it moves on to the next line. And this is the one that throws the error. And the specific error it throws is an index error. And now we know to give them good data. We can tell them specifically that the item that you tried to call does not exist in this list. Now, it doesn't necessarily have to be a list. It can be anything that has index position. So we've also worked with strings and string slicing. So let's say, for instance, that I've got a string that is hello. Now, hello has 5 characters in it, but it's only got 4 index positions, right? H is 0, E is 1, 2, 3, 4. So the O would be the 4th position. So what happens if I try to add, I'm going to call this my string. Okay, so what happens if I try to access, let's say, -7 character in this string? Well, -7 won't exist because 0 will be -1, L will be -2, the other L -3, -4, -5. So -7 doesn't exist. It would be somewhere before the string starts, which means that I can't access the character that's in the -7 position. I also can't access the character that's in the 5 position or the 6 or 7 or anything out the end of the word. So anything that's trying to access on either the left side of the existing string or the right side of the existing string that just doesn't exist should give us an index error saying that item, in this case, it's going to be that character, does not exist in the string or in hello. Okay, so this should give us a similar error. My list is not defined. Oh, what am I doing? I got to take this part out. Sorry, I don't need that part anymore. Let's run it again. Okay. Still trying to find my list instead of my string. There we go. Okay, so now it's run the first part successfully. Still gives us 0.0. But now when it's looking at the string hello and it's trying to find the -7 index, it doesn't exist in this particular case. So it throws an index error, and that index error specifically tells the user, our exception for that it doesn't exist. And again, it wouldn't matter if it was out the left side of the string or the right side. If I try to access the index of hello, it doesn't exist either, so I'm going to get the same error. So when you're able to put in more specific exceptions into your code, you can give the user better data on what the problem is. If there's only so many things that you're probably willing to check for, but you can make a general sort of exception at the end that catches all the specific ones, or that catches all the errors that you didn't specifically catch. So let's say I'm only looking for 0 division errors and I'm only looking for index errors, but let's say the user makes another error that's sort of outside of the scope of these two that we've got programmed for. You can do something called a finally. And finally is like an else. It's like, okay, we tried everything else above, nothing worked. So at the end of the day, we still have to have a message that says, there was an error. We don't know what it is. Obviously, you'd like to not get to this one, but you can, oftentimes you can only protect against so many specific errors. And sooner or later, you got to tell them, well, it's not a 0 division error. It's not an index error. It's not a runtime error. We don't know what it is, but there's still something wrong. So you could use this as a programmer to check to see what errors you're getting, or you could use this to show it to the user so that they know that something's wrong. You should go back and look at your data and see what the issue is. So when I run this, okay, nothing's going to change for this part, but it did do the finally. It's because I've got my finally coded somewhat incorrectly, because we only wanted to print one of these. We wanted to print the 0 division error, the index error, or the finally. I believe if we put break statements in here, it'll skip over the finally, but I'm just going to check my notes again because we'd like to not have to put that in there. It seems like extra coding to me. Just reviewing this stuff, we've gone through all this. That's just catching the specific error. And this one here, I've got 4 different errors it's trying to check. So I've got a name error, a division error, then I've got something called a type error. So if, say, you try to divide a number by a word, the data types don't work because you're trying to divide an integer by a string, and we know we can't do that, so it's going to give you something specific called a type error. And then there's also a runtime error where the program just doesn't start. So that's a more general kind of error too, but we're checking, the point in this one is we're checking for 4 specific things. So if it's any one of those 4 specific things, we're going to get the proper error. In this case, we've got A equals 5, B equals 2, and C equals the string high. What we're trying to do is print A divided by C. So we're trying to print 5 divided by the word high, which clearly isn't going to work. We can't divide an integer by a string. And the specific error that raises is going to be the type error because the data types don't line up. You can't divide an integer by a string. So the string part is the data type problem, and that's going to give you a type error, which means it's going to print you can't divide by a word, and then it's going to get skip all the other stuff and get outside and run the rest of your code. This one's a little squirrely depending on which version of Python you have. Sometimes you can check for multiple errors in the same line. So for instance, if you're looking for specifically a name error, a value error, or a type error, you might feel like you can handle all of those errors with one message to the user. So you can use them in with separated by commas, and if it hits any one of those, it'll print out that line, and then you can check for whatever else you want later. But I found that one's a bit squirrely on Python sometimes. So if you do try to use that and you're getting an error, you might just have to check them one at a time. You can raise your own special types of exceptions. You can actually code it so that if there's some sort of error that you're expecting that isn't handled by the ones that are built in and common errors, you can actually build your own specific exception and a specific accept block. You're not going to have to do that in your class, but in this class, sorry. But I want you to be aware that you're not necessarily just limited to these. And you can use your own types of exceptions for that. So what's this one doing here? Okay, now I've got some logic in here that is actually handling which errors you raise. So in this case, I'm telling it what to raise, and we haven't seen that raise word before. Raise just means instead of the Python automatically telling you what the error is and raising that exception and then moving down to the accept block, you're telling it specifically, if they do this, whatever it may be, I'm going to raise this specific error. And as soon as that specific error is raised by the program, it'll just go down to it down here, and then it'll do what you ask it to do. So in this instance, I've got a try that says, and an if statement inside a try. You can have whatever you want nested inside a try statement. It's if the type of x is not equal to an integer. Well, if we look up at x, x is an integer. So if the type of x is not an integer, okay, so then it's going to raise a type error. And then I've got an elif saying if x is not equal to 5, I'm going to raise a value error. So these are going to run in order, right? So the type of x not equal to integer, that's going to be false because the type of x is an integer. So the if is false, which means it's jumping to the elif. And I could have used an else on this one, but I wanted to put in the logic for this one. So elif x is not equal to 5. Okay, well, that one's true because x is not equal to 5, x is equal to 4. So what it's going to do here is it's going to raise the value error. And when it raises the value error, and you told it to do that by typing raise value error, it's going to skip over and go to the value error and say you've got the right data type, but you don't have the correct integer. So that's a way that you can sort of control what gets raised and control which accept it's going to without completely relying on Python to figure it out for you. So that can be a handy little chunk of code there if you want a bit more control over the errors that are being raised and thus the messages that you're trying to give to your people. Okay, now you can't raise a custom exception until you study classes in Computer Science 30. We don't have classes built into this. There's specific type of structures, and we don't have time for it in this class. It's in Computer Science 30. If you're still using Python in Computer Science 30, depending on if you're taking the class, obviously, and who's teaching it, you may be using Python, you may not be using Python. If you are using Python, you can actually build in your own errors, and they don't have to match up with the ones that are defaulted in Python. So instead of having to raise a type error value or index error or zero division error, you could literally make your own error that is called whatever you want. So you could raise temperature error or something like that, and then have an accept built in for temperature error that does something specific. So in this class, you're only going to use the ones that are built in, but it is possible to create your own custom exceptions. You need to know how to use classes to do that, and classes are a specific structure, and you're not going to see them in this course. So be aware that you can build your own try accept blocks with very specific error types, but not in this class. I've got a list of sort of the most common errors that are built in, and I see it kind of chopped off here, so I might look at that slide and I'll put them in. I think I had like 7 or 8 of them that are common errors that you're going to see a lot of the time. In this class, when you've broken your programs, you've typically seen index errors, or you've seen name errors where you put in a variable x equals 5, and then you try to access y, and because you didn't have a y variable or something like that. So for instance, let's say you've got a and you've got b. What happens if I try to print a divided by c? Well, there is no c, right? So if there's no c, you get a name error, right? So it says c is not defined. Basically, you tried to access a variable that doesn't exist, and you could fix that easily enough, by going c equals 3. Now c exists, and you're not going to get that error. So there's all these different types of errors that you're going to raise, and if you try to access a variable that doesn't exist, it's going to tell you that that's a name error. If you try to access or if you try to do something where the data type doesn't match up, for instance, that situation where we tried to divide a number by a word or a string, then it gives you another very specific type of built-in error. That was the type error, right? You can't divide an integer and a string, so it's telling you very specifically that's your mistake there. So there's a lot of these errors built in, but you're going to see some more often than others. And the index error, the type error, the name error, to some extent, the division by 0 or 0 division error is going to be something that you're going to see. I don't think you'll see a whole lot more than that. Sometimes you just get straight syntax errors. But you're those are the ones that you're more likely to see. You're unlikely to see the memory error because most IDEs just kind of end and crash when you put an infinite loop in. But you could also raise memory errors if you have an infinite loop in your program and it just keeps running forever because you didn't find a way, because your logic was flawed. It'll raise a memory error saying, we tried to do what you wanted us to do, but we ran out of memory because it's going to run forever. So I'll update this slide and make sure that you see the most common errors you're going to see. And those are errors that you're going to make, but those are also errors that the user is going to make when they try to put in data. If you say, what number do you want me to divide by, and they type in the word high, that's not really you making an error, right? Your code will probably work if they enter a number, but if they enter a string, it's going to break. So that error is on the user, but we have to prepare for that, okay? This is the finally I was talking about. You can use a finally statement is placed at the bottom of try except. Code within a finally statement always runs after the execution in the try and possibly the except block. So that's why I ran into that situation where it was printing multiple times. Frankly, in coding, I don't use finally very often, and the reason I don't use finally very often is because of what happened when I showed you this chunk. Okay, so my program raised an error. It specifically raised this index error. So it printed off my index error exception, what I wanted it to print, but then it also ran the finally, which is confusing because it basically told you this was the error you had, and then at the end it says there was an error, we don't know what it was. So the finally would be used for something that you wanted to run for sure. So whether it ran what was acceptable in the try or it ran one of the errors, it's always going to run that finally. So, this might be something where it's just a catch-all. This is, just so you know, you made an error. I don't know, in case you want to make the user feel bad or something. So, that would make a bit more sense. They make an error. You tell them what the error is, and then at the end you just say, a message, hey, don't forget you made an error. Now that's kind of a useless line of code right now, but there are situations where you're going to want to have a finally run after it either successfully does the try or it does one of the exceptions. You're not going to see it much in coding. I very rarely have ever had to use finally in my code. So it exists. That's what it does, but you're probably not going to have to use it much. All right, what have I got here? Okay, so now this is where it might be more valuable as the catch-all in the end. Now, sorry, I kind of digress on that. This will be useful for you if you're not able to catch all the errors. So let's say that, for instance, the error was not one of these two. Okay, so the try didn't work, the error wasn't one of these two, and then it finally prints something. For instance, so let's say I'm not going to raise a zero division error or an index error. I'm going to raise some other type of error. So if I try to divide D by my string, we know that's going to give us an error because I can't divide by a string, but it's specifically the error that it's going to raise is a name error. And we don't have a name error handled in here. We've only got zero division and index error, so it's going to print the finally. Operand type, print D divided by my string. Oh, okay. So the finally is not working for that. Because it did raise the error. You can see it raised the error, but it didn't run the finally. So yeah, so that kind of goes back to my point that using the finally is useless. However, if I just put a blank exception in here, it should run that. So let's just let's just check that to see. Print some other error. Check this, make sure it works. Okay, so in this case, it raised that name error. Name error is not handled by this. It is not handled by this, which means it's just going to go to the next one, and that's where you're going to get your generic. Hey, there's some other error. We don't know what the heck it is, and then program finished. You know, if I did know that it was possible that they were going to try this, it would be in my best interest as a programmer and more useful for the user if I specifically program in if there's a possibility that they're going to enter some bad data that gives us a name error, I would try to specifically program it in to catch that. So, you know, in this one, I'd say you can't divide by a word, and that would catch that error specifically, right? Oh man, why is that? It's the name error, isn't it? Oh, type error, sorry. Like type error, not name error. So now it says you can't divide by a word because I specifically looked for type error. And then if I change it to something that's none of those three things, then it's going to run the kind of catch-all except at the end that just says it's some other error. Let's say if I try to print C, C doesn't exist. Okay, so it says some other error because trying to print C is going to raise a name error, and we don't have a name error handled. We got zero in division, index error, type error. We don't have name error. So it just goes down to the one of the exception at the bottom and says, hey, that's some other error. We don't know what it is. So that's something that you use a lot more often as a catch-all than using a finally. Oops. We checked for a couple different errors. We still don't know what was wrong. And that's only gonna work. Yeah, this is only gonna work if it actually tries or accept. So again, this is a pretty limited use. Much better to just put in except colon, so that will catch any other exception that you don't have specifically handled. So I might update that slide. I kind of borrowed this slide from a university prof, and I probably should have checked that part because I think he's wrong. And by extension, I'm wrong. Okay, why do we use it? Again, the review is we want to stop our code from breaking. We want to give users another opportunity to enter data or to do something that we ask them to do. And usually, if we're using in this case, we want to do it inside a loop. So you give them a second chance to enter their data, right? You want them to enter in data. If they do it right the first time, that's great. If they don't, you want to try to tell them as specifically as possible what you did wrong and give them another opportunity to enter the correct data. So A, your program doesn't break. B, when you get to the next part of your program, it's going to run properly. So using a loop with your exception handling is the best way to do that. Okay, so for instance, let's create a program that divides two numbers. Okay, so let's get data with user num1 equals, let's make it an integer, and the input's going to be enter a number. And then we'll get a second number, user num2 equals, same thing, int input enter second number, not 0. Okay, so we're trying to tell them. You always try to tell the user what to do and how to do it properly, but we know that users are going to make mistakes. Now, what are we going to try to do? We're going to try to print your user num1 and comma quotes divided by user user num2. Remember, I'm using the commas so that I can mix data types in my print statement. Is equal to, and that's going to be equal to user num1 divided by user num2, and whoops, user num2. Okay, and so if they give us good data, it should print off the try. If it doesn't, it's going to give us some sort of error. But the problem is, if we run this, okay, so I'm going to enter, first I'll enter 0 and then 4, and it's going to say 0 divided by 4 is 0.0, program finished. That worked fine. But what if they make an error? Okay, they type in 4 and then they type in 0. It tells them, hey, you tried to divide by 0, even though we told you not to, but then it's program over, right? So they don't get another chance to enter a number, and that's of limited use. So what we want to do is we want to give them another opportunity to enter the right value so that we can actually get to the next part of the program usefully. So they never got to see an answer, right? They never got to see, 0 divided by 4 is 0. They never got an answer. We told them what their problem was. We finished the program, but we didn't actually do what we wanted to do with the program. And that's why looping these things is going to make it more effective for the user. So what we're going to do here is let's just use while and break. We could use flags if we want, but I'm just going to use a while true because it tends to be useful when you're doing tries and accepts, because while true is just going to keep running until we get what we want. We don't have to look for anything specific. It's just we're going to break out of the loop whenever we know we've got good data. And we'll know we've got good data as soon as the try section is successfully completed. So this is one of those instances where using a while true probably makes sense. But again, when you're using a while true, you got to be careful you don't get an infinite loop, because we don't have any flag up there in the while statement to stop it. We're just saying, hey, do this, and then at some point you got to trust me to break out of this. Okay, so what do we want them to do? We want every time it runs through the loop, we want to get numbers from them, and hopefully we get the right numbers the first time, but maybe we don't. So don't forget to indent once you start putting it inside a loop or an if statement or something. So what we're going to try to do is get those two numbers and then give them the proper response. Number 1 divided by number 2 equals something. If it is successful in doing that, I want to break out of this. I want to break out of this loop. Okay? Otherwise, it's going to run forever. And now I've got a couple of other specific errors built in, okay, that says, let's say you've tried to divide by 0. That's probably going to be the most important one. We don't need an index error in this one because there's no chance we can get an index error with what we're trying to do. We're not using lists. We're not using strings. So that one doesn't really matter. I could get rid of that one. Definitely, I could put in you can't divide by a word just in case they entered a string and for some reason it couldn't turn it into an integer or something like that. And then we could also have the except that says some other error, just in case they type in something that really screws up our program. So let's run it, and let's give it good data and make sure that part's working. So if we enter a number, and we give it good data, so we're going to enter a 4 and we're going to enter a 6, that should be fine. And it runs, it does the try successfully, it breaks out of the loop, so you notice it didn't keep asking us for numbers. And it gave us our proper output. It said 4 divided by 6 is equal to 0.6 repeating, and then program finished, so it got to the end. So that's great. That's best case scenario. They enter what you want them to enter, and it works properly. Okay, so let's try and break it. Okay, so let's do, instead of dividing by an integer, let's divide by 0. I guess 0 is an integer, but we're going to divide by 0, which specifically my program tells you not to do, and we know that should raise an error. So when we hit OK here, you notice that we get feedback down here that you tried to divide by 0, but instantly it popped it up again and it said, hey, try it, basically enter a number, try again. Okay, so I'm going to make the same error because I'm still not reading it properly. It goes and it gives me gives me some feedback saying you tried to divide by 0 again. Okay, so now I finally read it and I go, oh, okay, well, I'll do 4 and 4. Now I get my data is appropriate. I get 4 divided by 4 is equal to 1, and then it finished my program. So that's actually a useful structure, because we're just telling the user, keep trying until you get the right answer. If you don't do the right thing, I'm going to try and give you some specific feedback that you can use to do the right thing. And then after that, it's just going to keep trying. And once it's successful in actually getting the data it needs, we've got it we've got a break statement so that a break will break out of this while loop. So we're making sure that we don't have an infinite loop in here that's going to cause us some problems. You don't need breaks in the accepts. Specifically, you don't want breaks in the accepts, because if they have a problem, if they type in the bad data, you don't want it to break out of the loop. The whole point of the loop is that they keep going and keep trying until they get it right. So let's see if I can break it a different way. I enter in 5 for the first one, and then I enter in hello for the second one. It broke right away. Invalid literal for string with base 10. Hello. I've got a value error. However, you notice down here, I don't have a value error handled, and for some reason it didn't hit the accept. I'm actually not 100% sure why. But if I have a value error in here, yoink. Oh, I know why it is. It's because I tried to make it an integer right away. So it actually broke right here, which is before my try statement. Okay, so maybe if I want this to be even more useful, I take these. I'm actually glad that error happened. Maybe I take those input statements and I put them inside the try, because if they make an error, while they're straight up entering data in, okay, we're going to know right here inside the try that there's an error, and then it's going to tell them what the error is. Whereas before, we were taking in, when our input statements were outside of the try, we were taking in the data, but we didn't give it the opportunity to check if I can actually turn this into an integer. Python can't turn a string into an integer, so the error was happening before we got to the try loop, or the try structure. So now that it's inside the try structure, if that breaks again, now we're kind of we're set up for it. It's not going to break the program. So I'll do the same thing. I'll type in 5. I'll type in hello. And now this time you notice it said some other error, because when it tried to do the integer conversion of the string, because it's inside the try, we've set it up to handle any error just by having that blank accept at the end, or that open accept at the end. So it tells us there's some other error, but it still continues to run the way we want it to run, where I can enter in some more numbers and eventually get the thing working. So that's a better way to do it, actually, is to put your input statements inside the try, so that any error on anything they type is going to be caught. So I didn't have that error specifically handled, but I could do that easily enough. So that was what did I generate there? I generated a, well, I guess I'll have to look. A value error. That's what it was. Okay, so a value error. And this one could say the same thing. You can't divide by a word. In fact, it's never going to get to the type error, because it's going to hit a value error before it tries to divide. So this value error is going to be raised right here when I try to enter the second number. Whereas if I was successful doing this, this right here is where the type error was going to be generated. So it's always in order, right? Wherever your error occurs, that's the first thing it's going to check. In this case, if I get it to type in hello, it's going to hit the error right here, right in the line 11. And then because it raised a specific error, you can't divide by a word. Well, I've got the same prompt for both of these. I probably shouldn't have done that. Let's put a, oops. This one would be type words or something like that. Now we'll make sure that we're getting the value error. Okay, so don't type in words, which means we know it did the value error. Okay, and then it does what we want it to do. It says, try again. Now I'm going to try 4 divided by 0. Oh, you tried to divide by 0. Try again. Okay, is there any way I can raise? What else? What other errors do I have here? I'm not even sure. What else could I raise here? I'm not sure, actually, that there's a whole lot else I could do to break this thing. So I don't know how to get down to some other error, because there's not much I can type in. I can either put in an integer that's 0 and it'll get this one. I can type in a word and I'm going to get this one. And I don't know that there's anything else I could actually type in that would generate any other error. So that's, you could basically handle all the potential errors on this program with just a zero division error and a value error. You could handle everything. But you certainly might need to include more of these depending on what data you're trying to take in and what you're trying to do with the data. But, like I said, for this one, really the only two errors that could possibly occur are zero division and value. Okay, so that gives you some a little bit more feedback on how to get good data from your user. If the term you might hear in industry or in other classes or whatnot is sanitizing data inputs or sanitizing database inputs or something like that. Sanitizing just means cleaning up, right? So what you want to do is you want to take what the user types in, and you either want to clean it up so that it works with your code, or you want to give them the option to type in good data. For instance, if I need them to type in a lowercase word and they type in an uppercase word, I don't necessarily need them to type that in again, because I can take what they gave us and just use to lower to get what I want, right? So for instance, if I just got a my word and I tell them that I want it to be, strings or inputs are strings by default, so I don't need to do anything else there. I want them to enter a word, but I know for the rest of my program, let's say I'm looking for the word A. So if A in my word, print, there's an A here. Else, print, there is no A here. Okay, so now here's an example where we can sanitize data input. So let's just let them type in a word. I'm going to type in ABC. Clearly there's an A in there, but my program says there is no A here. Why does my program say that? There's clearly an A. It's the first thing I typed. Well, we're looking for a lowercase a here, and they typed in an uppercase A, and those aren't the same thing. So this would be an instance where you could use a loop and put in some more code up here that says make sure you enter lowercase letters, but people don't read. So this is an instance where we can sanitize what they put in and not actually have to ask them for more input to frustrate them further. So we know that whatever they type in, we can turn to a lowercase by just going dot lower. Okay. So input dot lower, I've got it in the wrong spot. Got to be after that. So input, a word, and then whatever they type in, I'm going to turn it into lowercase. So now if they type in an uppercase A and no lowercase a, it's still going to work. It's going to say there is an A here because you sanitized their input and took all their uppercase A's and turned them into lowercase a's. Now, why might that be helpful for some of the stuff we've done so far? Is a lot of people have stuff like this. Say enter Y to continue, enter N to stop, and then the user, me, looks at that and goes, yeah, I didn't specifically ask them to error check, so I will type in what they want. But if I type in Y, it's going to break, and if I type into, if Y in Word, print, continue, and then I would have an elif, say if elif N in my word, print, and then you could have an else saying, type one of them. Now this isn't looping, I'm just giving them feedback. So let's say, this is what you want. You want a capital Y, and I'm going to give you a capital Y, but we're looking for a lowercase y down here. So I probably should have this opposite, right? And enter lowercase y to continue, lowercase n to stop. So if I type in a Y, I've followed your instructions, but let's say I typed in a capital Y instead. Okay, so now it says type Y or N, should have said. Type Y or N. Well, I typed Y, right? But the user might not recognize that, it matters if it's uppercase or lowercase. So once again, we could sanitize this really easily by just putting in a dot lower, so that if they type in a capital Y, it's still going to run this part. Okay, if they type in a capital Y, it's still going to be true. or if they type in a capital N, it's still going to be true. If they type in anything else, then it's still going to give them the error. So now if I type in a capital N, it caught it, right? You see N, and then it says end, which is what it was supposed to do. So it doesn't matter if I type in a lowercase or an uppercase, it's going to catch it. So we can sanitize user inputs automatically if we can handle, if we know what the common error is and it's like a lowercase uppercase thing. But you don't want to have to rely on that for every error in the program. So you want to be using try and accept as well in case you need to get them to re-enter data and you're checking for multiple different types of errors and specific errors to give them good feedback. So you can do error checking and data sanitization using try and accept, and you can also do it without using try and accept, or you can do it with a combination. The ideal situation is that it always comes down to user input and user experience. You want to make your program as flexible as it can be so the user can make some mistakes and you can still get good data to run your program. And ideally, you can run your program with the data they've given you without having to ask for it again, because that frustrates the user having to do things over and over again, even if they're the ones that made the mistake. Sometimes you can correct it automatically by yourself with your code. Other times you're going to have to put some try accept features in there because whatever they gave you, you just point blank can't use it. So you've got to tell them this is a type error, or this is, you can't use words or whatever, and get them to keep inputting data until they enter the right thing. I mean, just think of someone who, enters a password or something and they enter it incorrectly. You can't just let them into their phone, right? You have to tell them your password's incorrect, try again, okay? So some errors you can handle, other errors you just can't. You have to tell them this is wrong, do it right. So that takes care of try and accept. And we're going to go through your Python exam starts tomorrow. And I would suggest that you start it. And remember, you can save along the way. There's multiple choice questions, but there's also, in this second exam, there's also sections of the theory portion where you actually have to code things or just share little snippets of code to demonstrate to me that you understand how to use looping and range and steps and negative steps and things like that. So it's probably going to take you a little longer to do this theory portion than it did the first one. So I'd recommend that you start right away and answer the questions you can answer and you're comfortable with, and then save it. And then if there's questions that you're not quite sure about, it's open book, so you can use all the resources and videos. And as long as you're not, copying and pasting or stealing other code from the internet or other people, or working with other people in the class, should be you on your own. But if you need a little extra time or a little extra research to answer some of those questions, just save what you have and go do what you need to do, and then come back and finish it later. And same thing for the practical portion. It's only one. You have a choice between two programs, so you have to do one of the two programs, and you may not be able to build it all at once, or you want to take a break or something's happening. Just save it on your computer like you would normally save your Python files, and then go back to it whenever you're able to go back to it, finish it up, and when you're done and you're happy with it, and you've checked it over for comments and all the formatting and stuff, and you're happy with it, then you just hand it in. So don't feel like you have to do it all in one sitting. In fact, I would recommend that you don't. And we're probably going to do a sort of general review on all the stuff for exam 2 for our Wednesday session. So if you feel like there's a couple things or a couple concepts that you still don't understand even with the materials, good idea to attend that Wednesday session and maybe come armed with some specific questions that I can answer for you. I cannot answer questions from the exam, but I can certainly give you input on a process. So for instance, don't ask me a specific question about looping from the exam. Go find a sort of a similar or general form of I'm having trouble specifically looping with step values, and then I can address that without specifically giving you the answer to the exam. So hopefully that makes sense and helps you out. And as always, I'm available for help by email. Just shoot me an email and I'll do my best to help you out. All right, so thanks for your attention today, and hopefully your week goes well. And I hope that you are able to close out the quint in the school year on a very high note in all your classes. Take care.